So 11.1 is called parameterization of curves. Okay. So what exactly is parameterization, right? So what does it mean to parameterize a curve? And so we've seen curves before, right? So um, we graph them on the XY plane. And so essentially parameterization means the X and the Y will be dependent sort of on a third variable. And so essentially you'll have X is equal to F of T and Y is equal to G of T. Okay. So X and Y are now going to be dependent on the third variable, which we typically use T. T, by the way, is an arbitrary variable. We sometimes use theta as well, but in this case, we tend to use T as our third variable. So T is called the parameter. Okay. X equals F of T and Y equals G of T are called parametric equations. So these two are called your parametric equations. Okay. So now, first thing you might be wondering is, okay, well, okay, why do we want to do parameterization, right? So why do you use parametric equations, obviously in calculus? So why use? The first one. Okay. Use that one. First one. Okay. If my graph happens to look like this, right? So the curve cannot be represented by a function. So there's no function notation whose graph or curve is going to look something like this. So you use parametric equations to do that. Second, okay. Let's say the curve is indeed a function, right? So for example, right, the curve goes something like this. It's a parabola. Okay. And so this is certainly a function, right? So we know we can write this as y equals f of x. Okay. But then the function notation does not tell you, let's say if t happens to be time, by the way, that's why we tend to use t often, because usually t represents time. So y equals f of x tells you where the object is, right? So if this is the path of an object that's in motion, so it will tell you where it is, but it will not tell you what time it's actually at that position. So by using a third variable, it gives you, allows you to specify t, which is typically time, an object will be at each position. Okay. So it allows you to do that if you have parametric equation. And the third one is not as obvious because obviously we haven't done this part yet. But in 3D, parametric equation is the only way to represent curves. So you cannot use functions and you cannot use equations, regular equations, x and y, because typically an x and y equation will be a surface. So any equation and any function in 3D is going to be a three-dimensional object, which means it's going to have a surface on it, which means it's not a curve. Okay, and so one of the ways to represent a curve in 3D is to use parametric equations. So that's why this is sort of important, because that's what you're using in 2140. 2140 is when you do multivariable equations, and multivariable means you have surfaces, 3D graphing. And so the only way to represent, or one of the ways to represent a curve, is to use parametric equations. Okay. Questions? Any questions on this? Okay. So on this section, we're gonna go over the different techniques on how to parameterize a curve or a function, right? So if I gave you a curve or a function, can you parameterize the said curve, okay? And that's what the focus is on 11.1, okay? All right, so the first method, okay, we'll call it sort of the straightforward approach. So this will depend on what equation your curve represents. So if your equation is y equals f of x, or x is equal to g of y, okay? So it depends on which one you can solve for. So can you solve for y or can you solve for x, right? So either one would work. So if you can solve for y, then this is your parameterization. So you let x be t, right? So x would be your parameter, and then y would be f of t. Okay. And then same thing on this one, right? So here y is going to be your parameter. So y would be t, and then x would be g of t. So some examples. So number one, so direction is to parameterize um, each curve. Okay. So here's your X and your Y. Okay. So obviously you're going to be given a curve. Okay. So this one is 4, this one is 2, this one's -2. So this is y equals x squared, sorry, 4 minus x squared. Okay. All right, and so since it's y as a function of x, right, then the easiest way to parameterize this, and so since y is dependent on x would be my parameter, so x would be t, and then y would be 4 minus t squared. And there is your answer. Questions? Any questions on this? Let's try another one. Right, so parameterize this curve for me. So 2x minus 3y equals -6. So that's a line, right? That's your curve. So parameterize this curve for me. I know it's not a curve, but all right, can you give me one answer? So one answer is similar to this one, right? So you let x be t, and what would be y? It's 2/3 x plus 2. So solve this for y. And so when you do, by the way, there's more than one way to write your answer, right? So move this one over, but you can either write it as y equals 1/3 2x plus 6, or as sort of some of you were doing, distributing the 1/3, and you get 2/3 x plus 2. There's another one, right? So if you let y be t, what will x be then? So you can do that because you can also solve for y for x instead of y. So if you solve for x, you're gonna get what, 1/2 3t minus 6, right? And that would be another answer. So which means parameterization is not unique, right? So there's more than one answer to a problem, right? So for example, on the first one, I didn't have to use t. I could have said x is 2t. So if x is 2t, y would be, so replace this with 2t, you would have gotten 4 minus 4t squared. And that would be the same parametric equations. It would be the same curve as that one. So there's more than one answer when they ask you to parameterize a curve. Okay. Questions? I think we have time for one more. So let's do another one. Okay. And then we'll finish this on Tuesday after spring break. Okay. So this curve is x minus y squared equals -1. So find me a parametric or a parameterization for this curve. All right, so give me your parametric equations if you did it. So just type in x equals y equals, right? So what did you use for this curve?
X equals T.
X, not x though, right? You should have done y, right? Because y you can move. So y would be t, and what will be x then? So y is t, and then x is, so move this one over, and then replace the y with t, and you get what? T squared minus 1. So someone was asking, can you explain which one should you use as t? And in reality, it won't matter. Okay, so it won't really matter which one is t. However, let's look at what happens if x is t. So if x is t, okay, then I have to solve this for y. And if I solve this for y, I would get y squared equals x plus 1. You move the x over and then multiply by -1. And then how do I get rid of the square? Square root. But remember, when you do square root, there's a plus or minus. The plus or minus means there are two sets of parametric equations. So when you say x equals t, you're going to actually end up having two sets of parametric equation, one where x equals t, and then y is the negative square root of t plus 1. And then the other one is x equals t, and then y is the positive square root of t plus 1. So you end up having two sets of parametric equations for one curve. And so that means this is a little bit easier because I can solve for x a little bit easier compared to solving for y. So since I can solve for x easily, I let y be t, and then my x function, or at least my x equation, would be simpler compared to what would have happened if I let x be t. Okay, I did. So over here, I let x be t. Oh, sorry. Thank you. This should be t. Thank you on that one. That should be t. It should be. So they should all be t in it. Anything else? So is this question um, understood, Rebecca? You now know why y was t instead of x? Okay, but in the end, it doesn't matter, right? So when you get to 2140, this would work. This is going to work. The only problem is when you do this in 2140, you're doing this for something else. You're going to do something else with it. And if you have two sets of parametric equations, you have to do it twice. So the nice thing is doing this, you're going to only have to do it once because you only have one set of parametric equations. But if you do it this way, you're going to have to do whatever you're doing two times because you have two sets of parametric equations. That's why, as much as possible, you try to avoid this. Okay. Any questions on that? So you try to avoid having to do a square root, and then you're going to have plus or minus. which now leads me to, we're gonna do this next time, so we don't have any more time. Um, so I don't want to mess up around my notes. Okay, I'll put it here. So what happens if this is my curve? So it's a circle. Remember, a circle is x squared plus y squared, whatever the radius. Let's make the radius 4 here. So that would be 4. So now how do you do parametric equations on it? Well, you look at that, x and y, if I do it this way, I will have to get this in the end, right? You're going to have to do a square root at the end. And so we need a better way to do this. So that way we don't have two sets of parametric equations. And we're going to talk about this next week or in 2 weeks. Okay. So we'll talk about this one next time. Okay. Anything else? No, I moved all the homework due dates to the week after. So whatever we finish Tuesday, it's due April 7th. And whatever we finish today, which is 10.10, is due April 9th. So those are due after spring break. There are homeworks open during spring break. So remember, I told you that all your homeworks are open during spring break. So they're all open. So if you missed any homework, spring break is when you go do get caught up on those, and they will close on Sunday. So the previous homeworks that are open, you'll have until Sunday to get them done. Anything else? Okay. So let me stop the recording.